Hello. Let us begin with a simple two-way classification of objects in R that we met earlier. Today I'd like to discuss lists and data frames. You remember that a list involves a range of elements all in a single dimension, and yet the elements can have different modes. For example, they can be numeric, character, or logical. With a data frame, effectively what we have is a whole series of lists strung in a two-dimensional framework, rather like the way a matrix is a two-dimensional representation of a vector. Let's look at how we create lists in the first instance. So lists are these generic vectors that allow elements of different modes, and we create them using the function list. So here's some ecological data, for example, and using the list function we might have banana, 7.2, true and pink. What is the mode of that eco data that we have defined in this way? Well, the mode is a list. But we can also inspect the individual elements within that list to find out what their modalities are. And to do that, we can use sapply, which applies a particular function to each of the individual elements of any given list or matrix or vector. So if we apply sapply, ecodata mode, then what we see is the first element is character, the second is numeric, the third is logical, and so on. Now let's compare the operator concatenate, which helps create vectors, with list, which creates lists. Let's imagine that we have a vector w that we're trying to define as somehow a mixture between these numbers and the character string dog and 9 there. Well, if we define it in this way and get it to print out, because we're using a concatenate operator which applies to vectors, then what R does is goes to the lowest common denominator, which assumes that all of the individual elements, in this case, are all characters. So we can ask what the mode of W is, and we see that it's a character. Now let's try this, where we have W1, which is defined as a list. So here we have different types of elements explicitly recognized, and we can ask what the mode of W1 is. Well, the mode of W1 is a list. We can now apply the mode to each of the individual elements of W, and we'll see that it forced them all to be characters because we used that concatenate function to join all the elements together. And yet if we apply sapply w1 comma mode, where we're asking what the mode of each of the individual elements within that list is, then we'll see that 3 of them are numeric, and yet the third element in that list, dog, is actually a character. So implicitly defining W as a vector makes R assume that all elements have the same mode, and if one element is a character, then all must be characters. So if you're creating data sets involving different types of variable, we use list and data frames rather than creating them using vectors or matrices. So let's get on to data frames. They're generic matrices comprising lists that allow elements to be of different modes. So they're a collection of lists, if you like. How can we create a data frame? Well, rather like the list function, here we can use a data frame function. And here I've got book data, which is defined as a data frame with each of these different columns referring to book, the author, the year, and whether the book was used or not used in terms of a second-hand bookshop. So using that definition of a data frame, we can now ask what the book data looks like, and this is what it looks like. You'll see that row numbers 1, 2 and 3 have been put in. We can, as I'll show you in a few minutes, remove those if we don't like them. But we have each of the individual columns, in our case named by book, author, year and used, and each of the different elements within that data frame. And we can refer to elements just in the same way as we refer to individual elements within a matrix by giving the row address and the column address. Let's have another look at data frames now. Let's have a look at this made up data with aardvarks deriving from different countries, and here are the litter sizes of our aardvarks. So we have 10 altogether, 6 of them from Kenya and 4 of them from Tanzania. Well, how would we make this data frame? Well, of course we could read it from a file if we choose, but for now let's just write it directly into R. So we'll say aardvark data is data frame. Well, we know that we're counting the individuals from 1 to 10, so a simple way is to say individual is equal to 1 to 10. What about the country? Well, we have 6 Kenya data points and 4 Tanzania. And to have Kenya written down 6 times, we can use the rep operator that we met earlier. So the country is 6 Kenyans and 4 Tanzania written after one another. And then finally, the interesting data that we have is the litter. So it's 2, 3, 4 all the way down to 2, 1. Well, we can create a data frame like that, and then we can ask questions. For example, we can say aardvark $litter refers to the litter variable within that data frame aardvark data. And the way we refer to the names of variables within data frames is using that individual $sign. We could, of course, simply ask it for the third column in our data set, and we could ask the same question in this way: aardvark data, square brackets, and then we're leaving effectively a space and then a comma and then a 3. So we're asking ignore the row, simply list the third column data, and there we have the same. In R, there's many ways to do the same thing, and finally here is a way we can attach the aardvark data such that when we refer to variable names within the aardvark data, we don't need to say where they've been derived from because that data has already been attached. So once attaching aardvark data, we can simply say litter and it would give us that data listed out here. But a word of caution, we should be very careful with attach because it's easy to attach more than one data set, and if those data sets share common variable names, you can get very confused about which variable you're actually referring to. So I always recommend that if you really need to use attach, then also detach that data as soon as you have finished using it. And I would strongly recommend that you don't attach several data sets simultaneously because life can get very confusing. So how do we add columns to a data frame? How do we add new variables? Well, here, for example, is one new variable. It might be the mean weight of those aardvarks in the litter for each of those individual aardvark mothers that we have listed out. So we would say aardvark data and then use the $sign for referring to a new element in this case, or a new variable within that aardvark data frame, and there I've got 10 separate values listed out. I can then ask what the aardvark data looks like, and this is what it looks like. We now have an extra column, mean weight, listed just there. Now, for some purposes, it may not be very nice to actually have an extra row there, as you can see on the left-hand side, which is inserted by default in R. If you want to simply view the data, we can simply say print aardvark data, but in this case we can apply the extra argument and say row names equals false. Thank you for listening to this R Labs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.